Good day everyone. In this video, we are going to discuss the different engine safety interlocks and their function. First, what is safety interlocks? Interlocks are provided so that the engine can be started or reversed only when certain conditions have been fulfilled. When there is remote control of engines, it is essential to have interlocks. This reduces the possibility of engine damage and any hazard to the operating personnel. So, different types of interlocks. First is the turning gear interlock. It prevents starting air from reaching the engine when turning gear is engaged. For example, ang turning gear is mauna imong patuyokon sa pagsugod pagpaandar sa main engine. Kung i-engage na siya, mo-connect siya sa flywheel. Then tuyokon na dayon tong mga moving parts sa engine. While naka-connect na sila, dili pwede pasudlon ang starting air kay pressurized man. So kung makasulod ang starting air sa engine, malabay ang atong turning gear. So ma-damage.
Running direction interlock. So this prevents the fuel from being supplied if the running direction of the engine does not match the telegraph. So the running direction interlock is an essential trait that prevents the injection of fuel to the engine when the telegraph doesn't synchronize with the running direction of the engine. So this is an important application in the crash maneuvering when the starting air is used to apply brakes on the engine by reversing the operation.
So starting air distributor in the end positions. So this prevents starting from the taking place if the shifting of the distributors has not been completed. Starting air systems responsible for providing pilot air to starting on air valves. So as per the correct starting order. So the injection timing of all cylinder is timed according to the firing orders. So starting air is to provide air on each cylinder through the firing order. So for example, our cylinders on board is 6 cylinders, and then the the firing order is 1 1 5 3 6 2 4. So that is the firing order. For example, the starting air is following cylinder to provide, or another term or provide is maghatag siya hangin into the engine. So then the air is entered to the cylinder, then the piston will move into bottom dead center or BDC to have an space for the air. So the piston will be moved down, then the air will be entered to the cylinders. So after that, the piston will be moved up to compress air to create and combustions. So after the move piston to down, and then the air will be the space of the cylinder. So the piston will be moved up, which is top deadly centers, and create combustion. So that's it. After the compressing, create the combustions, and then will until the shafts are rotate and gives wave of shifts. So for providing air into the cylinder, so each cylinder, so di ba ang atong pag firing order is 1 5 or etc. Dili man gyud na mag 1 2, dili man gyud na dapat, which is ma-damage ang atong camshaft. So atong gibuhat is which is 1 or the last number 1 6 or inana para dili siya magsunod-sunod. So the air is provided into the cylinder, and then the cylinder or the piston will be moved down, then the air will be entered into the cylinder, and after the move down, the piston will be up to compress and create combustions. So that's it. So I think that piston will be moved up and down to the shaft will be rotate. So it can give rotate to the propeller and the ship will be moved and give speeds. So I remember for previous discussion that our instructor said that the starting air system is applicable for four-stroke to distribute pilot air into the cylinder. Yes, that I remember that time. Before to it is applicable for four-stroke. So before to start the engines, there is a starting air to provide the each cylinder to to, to our engine is bugana na. So after that the bugana na siya, the starting air is automatically nga mapawang na siya. So that's it. So whereas the two-stroke engines have not need to starting air system because in that engines have an air blower to provide air and scavenge. So yes, the two-stroke engines they have an air blower to provide air. So dili na siya kailangan o starting air. So that's it.
So next is the auxiliary blower interlock. So what is an auxiliary blower interlock? The auxiliary blower is provided in the case of constant pressure turbocharging. When we are using constant pressure type turbocharger, it is inefficient at speed below 25% of rated power. So 25% or below ngayon ana, so it is very inefficient. So unsa may atong dapat buhaton to make an efficient scavenging. So we have to install an auxiliary blower to provide positive supply of fresh air charge. So auxiliary blower is used to supply the compressed air to the marine diesel engine during starting and maneuvering of the engine. So magamit lang ta ning auxiliary blower if ever ang atong turbocharger dili kayo sa ka supply og appropriate amount of compressed air sa atong engine.
Air pressure interlock. So, in case of the present generation of engine using exhaust valves shut by air springs, the air spring pressure must always maintain or else the exhaust valve may not close. So, in short, if the exhaust valves are operated by air spring pressure, there should be a sufficient air pressure before the engine can be started, or otherwise, exhaust valve may not close while running.